Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, good night everyone. So in this session, I would like to discuss beam analysis, beam with one redundant. Okay, let's say we have this beam. Okay, so this is 4 meter, 4 meter, and this is 16 kilonewton. Okay, so the label for this beam is A, B, and A, B, and C. So this is an indeterminate beam to the first degree of indeterminacy. So if we check for DOI, it is 4 minus 3 equivalent to 1. 4 minus 3 equivalent to 1. So there is one redundant in the system, and the redundant, let's say it is CY. Because it occurred at point C, so it is CY. CY. Okay. So based on this, straight away we can write the compatibility equation which we will write based on the displacement or the deflection at position C. So the position is position C, and CY is P, so we will calculate displacement. For the compatibility equation. Okay, so for the compatibility equation, so we will have delta at position C for primary beam plus with F. F is the flexibility coefficient. The symbol is F. Okay, F will represent delta. Okay, at position C for redundant beam, redundant CY applied. So we have to times with CY. Okay, and this is actually delta CC, and so this compatibility equation is equal to 0 because in actual condition when there is no support settlement, the value is equal to 0. Okay, the value is equal to 0. So inside this we have one displacement, two displacement. Means that we have two systems. System number one is called as primary beam, and for system number two, it is redundant beam. So we name this redundant beam as redundant CY applied. So we have two determinate beam to be analyzed. The beam is, okay, two determinate beam to be analyzed. Both are determinate beam. And it is the cantilever beam because the roller at C, we remove the roller at C. So for the primary beam and for redundant CY applied, okay. So we have cantilever beam, here subjected to 16 kilonewton, and remember this is cantilever beam and the system must be in equilibrium. Okay, so for total Fy, so there will be 16 to be balanced. Okay, so means that AY is equivalent to 16 because we need to fulfill total FY is equal to 0. Okay, it is 16 AY is equivalent to 16 because we have to make sure the system is in equilibrium. So 16 opposite with 16. 16 opposite with negative 16. So one going down, one going up. So for total FY, it is fulfilled. Okay, now we have to determine the moment at A. Moment at A for this cantilever beam. So it is acting in this direction and the value is 16 times 4. 16 times 4. So what is the value? 16 times 4. 16 times 4. 64. So you can write the comment, the answer in comment in the chat box. Okay, it is 16 times 4. 64, isn't it? It is 64. Okay, and 64 is acting in counterclockwise direction. So this is primary beam. This is primary beam. Okay, this is primary beam, and this is the reaction. Negative 64 is moment at A, and 16 is 16. Positive 16 is AY. There is no AX because this is beam, and AX is equal to 0. Okay, so we have complete the reaction in the primary beam. So we move to the reaction in the redundant beam. So we have to have the same type of beam. We have to have the same type of beam. Okay, it remain cantilever. It remain cantilever for both primary and redundant beam. Okay, the difference between these two type of beam is only due to loading. If in the primary beam, the external loading remain in the primary beam, but in redundant beam, okay, the only load that is applied into the beam is a unit value. It is just like the virtual system. So it is subjected a unit value of CY. A system that is subjected to a unit value of CY. Okay, a unit value of CY. So due to this a unit value, so this value is positive 1. So for the reaction, remember we calculate reaction to balance the system. Okay, means that if in the system there is one a unit value going upward, so there will be one downward. So automatically we will get this AY equivalent to negative 1. Negative 1. And for the moment, the distance from A to C is 8. The distance from A to C is 8. So the moment will be in clockwise direction and the value is 8. So that we will get 8. We minus by 1 times 8, we get 0. Okay, so this is the redundant beam. This is how it look like. Okay, so we have primary beam and we have redundant beam. Okay, we need to label. So label A, B, and C like this, and remain the same label A, B, and C. Okay, so what is the next step? Okay, remember as I mentioned, so in flexibility method, we have to set the goal, and the goal is, okay, the goal is we want to calculate we want to calculate reaction, and there are 4 unknown reaction. Okay, this is the goal. The goal is we have to calculate 3 unknown reaction, and 1 redundant. So this is our goal. So we will calculate these 3 unknown reaction using equilibrium equation, and we will calculate a redundant. We will calculate the value of redundant using compatibility equation. Means that once we have determined the compatibility, once we have the compatibility equation, we can solve for the redundant value, one redundant in the system, and then we can solve for the remaining 3 unknown reaction using 3 equilibrium equation. Okay, so that is why we have to have the reaction in the primary beam and in redundant beam, because from reaction we can write the moment equation. So why moment equation is needed? Because the moment equation is actually the input. Okay, the input, because these two value are displacement. Okay, it is displacement. Delta C naught is displacement in primary beam, and FCC is displacement in redundant beam. Okay, remember in structural analysis, there are 3 main steps when we analyze structure. First is reaction, second one is internal forces, third one is displacement. Okay, we calculate reaction from external forces. We calculate reaction from external forces. We calculate internal forces from reaction. We calculate internal forces from reaction, and moment equation that we write is part of internal forces. Okay, and then we calculate displacement based on internal forces. Means that in order to calculate this displacement, we have to write the moment equation. We have to have the moment equation. So that is why we have to have reaction, because in order to write moment equation, we have to have the reaction first. Okay, so from this, we will write the moment equation. You write the moment equation, because moment equation we will use in the displacement formula. The displacement formula delta, because delta C naught is actually 1 over EI from 0 to L MC M naught dx, and FCC is equal to 1 over EI from 0 to L MC square dx. Okay, now our task is we have to have the two moment equation. And as I mentioned, all the knot symbol is belong to primary system. So inside this, we can see that there are two moment equation. One is MC, one is M naught. One is MC, one is M naught. So M naught is for the primary beam. For the primary beam. MC is for redundant beam. Redundant beam. So this one is MC. So again, this is also not primary. This is redundant. This is redundant beam. So from this formula, we know that there are two moment equation. Okay, so which we get from primary beam and redundant beam. So this is primary beam and redundant beam. So for the primary beam, we label the moment equation for the primary beam as M naught, and we label the moment equation for redundant beam as MC. Okay, MC. We label the moment equation as MC. Okay, so from this, we will write the moment equation. So by looking at the primary beam, there will be two cutting section number 1 and section number 2. Okay, and then we have to put the right moment moment direction. Okay, let's say for member AB, we take origin at A. So the moment is acting counterclockwise. Let's say for member BC, the origin is C, and we take and the moment will be clockwise. Okay, so this one A. Okay, this is A as origin, and this is C as origin. So for member AB or for section AB, A is origin, so the moment is counterclockwise. And for member BC, C is the origin, so the moment is clockwise. So this is actually the moment M naught, M naught. Okay. So for the redundant beam, we have to follow the same cutting section. There are two cutting section, same cutting section. We have to have the same origin at A and at C, and the moment direction also will be the same. It must be consistent between the primary beam and redundant beam. Between primary and redundant beam, we have to have the same or the standard. Okay, cutting section, the origin as well as the moment direction. Okay, so this is MC and MC. Okay, so C is the symbol for the redundant. Actually, after this, we will change the C symbol to 1 because this is 1 redundant. So we will change C to M1, MC to M1 later on in the next example. Okay, so we have to write the moment equation. So normally moment equation, we will put into the table form as well. In the table, okay, we have to list all the members. Okay, we have to list all the member. So in this case, we only have two members, AB and BC. And then we have to write what is the origin that we choose. Okay, origin AB, origin A, BC, origin C. Okay, and origin, it is actually, we can choose any origin that we like. A can be origin for member BC, A can be origin, B can be origin, C can be origin. However, okay, always choose the shortest cutting section. Means for BC, the shortest is C. Okay, and then the limit X. Okay, the limit means for member AB, A from 0 to 4 meter. That is the limit. Means that A, the length is 4 meter. At A, X is 0. At B, X is 4. Okay, for member AB, origin at A, at origin X is 0. At B, X is 4. Okay, for cutting section number 2, member BC, origin is C. So at C, X is 0. At B, X is 4. So this is also 0 to 4 meter. So we have to have another 2 row, one for M naught for the primary beam, and another one MC for the redundant beam. Okay, so the moment equation. Okay, for the primary beam, okay, we have 16. We have 64. And this is the cutting section. The moment is acting like this. So this is M naught. Okay. And this is X. Means that this is 0. Okay, this position is A. Where is B? B is somewhere here. Means that at A, X is 0. At B, X is 4. So this length is 4 meter. That is why we put here 0 to 4. Because X can start from 0 until 4 meter. And 4 meter means the B position. Okay, that is why we get 0 to 4. Okay, doesn't matter. I erase this and this. Okay, so this is section number 1. This is section number 1. So this diagram is for section AB, origin A, and the limit is 0 to 4 meter. Section AB, origin A, from 0 to 4 meter, and by taking moment at the cutting point. Okay, to write the moment equation, we have to take moment at the cutting point. It is X. Okay, we do not take moment at A. Okay, moment at A2 for the reaction. Now we are going to write the moment equation based on the cutting section. Okay, so when we want to write the moment equation, we have to refer to the moment at the cutting point, which is X. Okay, so this is equal to 0. So from this, we will write the moment equation M naught. And M naught is, okay, please write like this. Okay, look at the diagram. So M naught is in counterclockwise direction, opposite with sign convention that we put for the MX. So it is negative M naught. Negative M naught. We plus by 16 times X. The distance from A to the cutting point is X. And we minus by 64. And this is equivalent to 0. So M naught, what we get is, it is 16x minus 64. 16x minus 64. So this is the value that we want. This is the moment equation. So 16x minus 64. 16x minus 64. Okay, next we move to BC origin C. BC origin C means this part. Okay, BC origin C. So for the diagram, so the diagram is just to help us writing the right moment equation. Okay, it is not compulsory for you to show in the calculation. Okay, so for section BC, so we have, okay, X is like this. Moment clockwise, this is M naught. That's all, because it is cantilever N. Okay, so this is section BC, origin C, and the X limit is 0 to 4. What does it mean? Okay, look at this. So this is point C. Okay, point C. Point C. What does origin means? Origin means X is 0. Origin means X is 0. And X is, okay, going to B, from C to B. This section is from C to B, not B to C, because because origin is C. So C is 0 position. B is located somewhere here. This is B. So at B, it is 4. The distance is 4. The distance is 4. That is why we write from 0 to 4. From 0 to 4. It is actually equivalent to the distance. Okay, from 0 to 4. Okay, so okay, this M is equal to 0. Okay, 0. So this is 0. Okay, for AB, redundant beam, MC. Okay, now if this is for the primary beam, this is all primary beam. This is primary beam. We will now move to redundant beam. And for redundant beam, okay, we have 1 and 8. Okay, the cutting section, the moment direction MC, okay, X, distance of X, this is X, okay, like this. Again, this is the same section AB, origin is A, limit is 0 to 4. Okay, so from this, by taking moment at X is 0, so we should write like this, negative MC. We minus by 1 times X, we plus by 8, it is equal to 0. So MC is equal to 8 minus X. It is 8 minus X. So this is the moment equation. 8 minus X we put into the table. So in this table, it is 8 minus X. Okay, 8 minus X. And the last one is here. The value is 1. The cutting section, the moment direction, which is clockwise direction, this is MC. Okay, the X, okay, this is section BC, origin C. So X is 0 to 4. So taking moment at the cutting point is equal to 0. So MC minus 1 times X equal to 0. So MC is equal to X. So the answer is X. So we put X in the table. Okay. Okay. So why I put this in the table and this in the table? This is the two table that must be compulsory for you to show. Okay, other than this, all the calculation. Okay, this is just the calculation you can do in separate calculation sheet if you want. But what most important is you have to show to me, okay, this diagram, these two diagram, one is primary beam, one is redundant beam with reaction value inside, and the table, okay, for the moment equation. The table for the moment equation. So we have to transfer this into the formula. Okay, so remember, back to the goal. We have two goal. We have one goal, but we have to separate into two. One is 3 unknown reaction and 1 redundant. So redundant will be determined using compatibility equation. Okay, what is inside the compatibility equation? It is delta C naught plus FCC times CY is equal to 0, and delta C naught is 1 over EI. Okay, for member AB, it is from 0 to 4. From 0 to 4. So refer back to the table for member AB. Okay, it is M naught times MC. MC M naught, right? MC M naught and MC square. MC M naught and MC square. So we have to time these two and integrate, and time these two and integrate. Okay, so MC is 8 minus X and M naught is 16X minus 64. So we have to integrate these two moment equation. Okay, so here it is 8 minus X and 16X minus 64 dx only for delta C naught, because this is for AB and BC is equivalent to 0. Okay, please integrate for me for the answer. Okay, the answer is in terms of EI. Please calculate for me the answer for this integration. Okay, it is from 0 to 4, 8 minus X for MC and 16X minus 64 for M naught. Integrate these two. What do you get? Integrate using calculator. Okay, please write for me the answer for the integration. 8 minus X and 16X minus 64. Okay, the limit is 0 to 4. Okay, negative 853.333. What about the rest? Okay, all get the same, Negative 853.333. So this is the answer for delta C naught. This is the answer for delta C naught. Negative 583.333 over EI. Okay. Okay, next we calculate FCC. 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 So it is 1 over EI. 1 over EI. For AB, it is 0 to 4. Okay. For AB, it is 8 to 8 minus X square dx. Okay, we have to plus with 1 over EI from 0 to 4 for member BC. Okay, 8 minus X for member AB. And we have X for member BC. So this is X square dx. We get from the table. We get from the table. Okay, it is 8 minus x because it is mc squared. For the formula, from the formula, it is mc squared. Look at the formula. mc squared. Okay, for FCC, mc squared. So we have to calculate for AB and then for BC. For AB, it is 8 minus x squared dx 0 to 4. And for BC is x squared 0 to 4. Okay, so what is the answer? What is the answer for this? Remain the answer in terms of EI, because EI will be cancelled whenever we solve the compatibility equation. So what is the answer for this? Eight minus x square dx 0 to 4 for the first part for AB, and x square from 0 to 4 for BC. You have to tick your attendance ya. Sekejap I want to set your future for the attendance. Okay, what is the answer for second one? For FCC, please calculate. So, online session, manage attendance. Okay. Okay, so yang ni group 7B1 and set together. PEC 221 4D 4D1. Date is 10 night session at 10 at 10 at 9 lah, start tadi 9:30 kan. Okay, I set at 9 to 11 PM. From 9 to 11 select platform. So 5D1 and 7B1. Save. Okay, please please tick your attendance. Okay, please tick your attendance. Okay, 170.66 So it is 170.666 over EI. Okay, so these are the two value. Okay, that we want. So the displacement at position C in primary beam and displacement at position C in redundant beam. One position at C position, but into system. Okay, so we want to substitute these two value into the compatibility equation. So for the compatibility equation, so we substitute negative 853.333 over EI plus with 170.666 over EI times with CY, it is equal to 0. So this is the compatibility equation. The compatibility equation for this beam when redundant is CY, okay, is written like this. So when we solve this compatibility equation, solve for the redundant, for the redundant CY, so we will get CY equal to 853.333 divided by 170.666, and we get the CY value. So what is CY? What is the value of redundant? What is the redundant? Redundant value is 5 kilonewton. Okay, so 5 kilonewton. So what is the next step after getting the redundant? Okay, so that is where we have to go back to the goal. Okay, when redundant has been determined, so we have to determine remaining reaction. Okay, so we can continue to calculate remaining reaction. Continue to solve for the remaining reaction. Okay, continue to solve for the remaining reaction. Okay, so draw the diagram. So this is 16. This is 5. So now BY, this is CY, right? So this is CY. This is CY. So replace the value of CY here. So we put 5 here. 5. Okay, and then having 5 like this, so we have to calculate remaining reaction at A. And looking at this diagram, again we have to calculate, and for this case there are 3 unknown reaction, remaining 3 unknown reaction that can be solved using 3 equilibrium equation. Remember, when we apply equilibrium equation, the purpose is to make sure the system is in equilibrium, means that total Fy must be equal to 0, total Fx 0, total moment 0. So by just looking at the diagram, okay, we should get the Ay is equivalent to what? What is the value of Ay? Just by looking at this diagram, So there is 16 kilonewton downward. We have 5 kilonewton upward. And what's the difference? The difference is the AY value. What is the difference? So what is AY value? What is AY? 11. Okay. So AY is 11. AX is 0 because this is beam. So we don't need to put the 0 value in the diagram. Okay, what about the moment? What is the value of moment at A? Okay, moment at A, what is the value? 16 times 4. And 5 times 8. 16 times 4, we minus by 16 times 4 is 64 just now, right? 64. So 64 we minus by 5 times 8 is 40. So the moment is 20. The moment is 20. It is 64 and 5 times 8, 40. 40, right? So it is 64 minus 40. So it is 24. So the moment is negative 24. Please check. The moment is 24. Is it the right one? The right answer. Twenty-four. Is it correct? The direction, the moment direction? Check, we check back. Okay, looking at the diagram, we want to check for the moment at A. Moment at A. Okay, this is just for checking. This is just for checking. For moment at A is equal to 0 clockwise. Okay, this is just for checking. So it is negative 24. We plus by 16 times 4. We minus by 5 times. This is 4, right? Sorry. This is 4. This should be 4. Not 8. 4, right? 4. Okay. So 5 times 8. Correct. Okay. This is 5 times 8. Do we get 0? Negative 24 plus 64. We minus by 40. Do we get 0? Negative 24 plus 16 times 4 minus 5 times 8. It should be 0. If it is not 0, means the previous answer is not correct. The system must be in equilibrium. This is just for checking. Okay, this is just for checking. We have to make sure that total moment at A is equal to 0. Okay, so actually this part you don't need to show for the solution. It is just until this step. Until this step. Okay, this is just for checking because I have put the value of MA directly just now. So I just do this for checking. So it must be 0, then only correct. This is the correct one. Okay, so now using this, we can continue to draw shear force diagram and bending moment diagram. Shear force diagram and bending moment diagram. Okay, so for the shear force diagram and bending moment diagram, we can draw easily, actually, okay, as simple as this step. Okay, step number 1, draw the diagram. Okay, draw the beam. Step number 2, put the loading and the reaction. Okay, put the loading and the reaction. So this is 11 and 5 and 16 and the moment 24. Okay, for the shear force diagram, okay, you have to draw the line. Okay, remember that we are going to draw the diagram in equilibrium, means that we have to start from zero position and the diagram must end at zero position as well. So from the diagram, okay, the upper diagram, okay, we start draw the shear force diagram by looking at the shear value. The shear value in the diagram is 11, 16 and 5. So this three is the shear value. Okay, so start from 0 here, okay, going up to 11, go straight until we meet 16, and then downward 16, and we get negative 5, because it is 11 minus 16, we get negative 5. So we go straight until we meet 5, and we go up because this is go up. So go up. So this is the last position. Okay, the process is like this one, and then this one, because of this, and then because of this we have to, means that start from 0, end at 0. This is the shear force diagram. The shear force diagram can be drawn, okay, directly without having the shear equation. Just draw by uh, looking at the free body diagram. Okay, just focus on the shear value. So draw according to the arrow. Okay, start from 0 position, 0 plus 11. This is 11 plus 11 going up, and then go straight until we meet another point load, another shear value. We follow the arrow, it is 16 downward, so move downward by 16 value, 16 kilonewton. So this point is actually negative 5. This point is negative 5. Don't worry, go straight until the last position, and at the last position we have to follow the arrow, it is going up, so the last position is 0. Okay, this is the shear force diagram. So this is positive value and negative value. Positive and negative. Okay, this is shear force diagram. Okay, next we will draw the bending moment diagram from the area of shear force diagram. From the area of shear force diagram, without writing the moment equation. Okay, previously you have learned how to draw the bending moment diagram by substitute the x value into the moment equation. Okay, that is another solution. Actually, we can draw the bending moment diagram by finding the area of shear force diagram. Okay, so draw the line. Okay, draw the line. Remember the diagram start at 0, end at 0. Start at 0, end at 0. So the first point is at A, and look at the diagram. At A, there is moment negative 24. Negative 24. So negative, okay, let's say we assume that negative is located here, positive is located here. Anyway, in beam, in BMD, we can actually draw negative upward, positive downward, doesn't matter. Okay, so now I just want to set like this: positive upward, above line, and negative below line. Okay, the moment is negative 24. means the point for negative 24 is located somewhere here. This value is negative 24. Negative 24. Okay? That is the first value. The first value. Okay, the next value is the value which is actually this is in under one line. This is under one line. This is under one line, dotted line lah. Under one line, yeah. Okay, should be dotted line. Dotted line. Dotted line. It is just like you draw the diagram. BMD and shear force diagram is actually we can plot as in the graph paper as graph. Okay, so that we can get accurate shape. Okay, now we are going to draw the bending moment diagram. Start from 0 value. The first value is negative 24. So that is why I have put here 24. So I don't put negative at 24 because 24 I have put at negative side. Okay, do not put negative 24. Just put 24, the value only because I have put under negative side. Okay, this negative 24. Okay, then we refer to the shear force diagram. Okay, find the area. Find the area of shear force diagram from A to B. From A to B. And this one is 11. This one is 11. 11. The length is 4 meter. And the length is 4 meter. The distance is 4 meter. The force is 11. 11. So it is negative 24. We have to plus because shear force diagram, it is positive. Under positive diagram. So it is plus 11 times 4. 11 times 4 will give us the position of moment at B. Okay. So can you please calculate? It is 44 minus 20. 44 minus 24. 44 minus 24, so we get 20, 20. So the value is 20. Negative 24 plus 44. So 44 minus 24. Kan? So we get 20, positive 20. So positive 20. So atas lah. So the point is like this. Okay. Maybe you want to put somewhere higher. Okay. This is the 20 value. Okay, 20 value. It is positive, so we have to put at positive side. Positive side. Okay. And next is we have to continue this. Negative means we have to minus the area. We have to minus the area. It is 5. 5, right? This is 5 and 4. So this 20, we have to minus the area of shear force diagram. For BC, it is 4 times 520. 4 times 520. So now it is 20. It is 20 minus 4 times 5. Sorry, 5 times 4. 5 for the force, 4 for the distance. So it is 5 times 4. This is 0. Okay, so the last position will be 0. Last position will be 0. So next, we just need to join the line. Okay, join the line. Okay, so like this. Oh, join the dot, not join the line. Join the dot, yeah. Okay, like this. And like this. Okay, so this is positive. This is negative. Okay, this is how the bending moment diagram look like. Okay, negative and positive. It is straight line because it is point load. Okay, so for the diagram, it will have curved line if the UDL is the external loading. So in this case, there is only one point load like this. So we will get BMD like this. Okay, the maximum moment at B, the moment at B is 20. Okay, at A the value is, the moment value is 24, negative 24 because of fixed support. And at C, this is MC, MC, the value is 0 because it is roller support. So moment is 0. There is moment value at fixed support and the value is 24. Okay, so this is how to analyze simple beam, indeterminate beam to the first degree of indeterminacy, one redundant. So most important is, okay, okay, from the redundant chosen, we should be able to write the compatibility equation, because compatibility equation will guide us what is the next step. Okay, so we have two displacement. So these two displacement, remember displacement we get from moment equation we get from reaction. That is why we start from reaction in two system, primary system and redundant system, and then displacement also from primary system and redundant system. So this is for the reaction, and this is for the moment equation. Reaction, moment equation. Okay, reaction and moment equation. The moment equation we substitute into the formula. Then we get delta at position C for primary beam and for redundant beam. Substitute into the compatibility equation like this. Okay, solving the compatibility equation, we get the redundant, okay, like this. And then we continue to solve the remaining reaction. We put the redundant value, the By 5 kilonewton at B, and then we continue to calculate remaining reaction at A using equilibrium equation. Anyway, there is another way. We can also determine remaining reaction using principle of superposition. Okay, but we will discuss in the next example. Okay, so just for checking, okay, to make sure the system is in equilibrium. Once it is in equilibrium, then only we can draw the diagram. Shear force diagram and bending moment diagram, we can draw straight away from the diagram like this. Okay, so for the shear value, just look at the all the shear, the vertical reaction and vertical forces. And for the moment, we have to start with the first moment at A, and then using the area of shear force diagram, we can calculate the next point until the end. Okay, since By at B, not By, this is Cy. Cy is roller, so we should get moment at C, which is equal to 0. So this is how the diagram look like. Okay, so that is all for today's session. I hope you can try to do the question given previously under quiz. Okay, try to follow all these steps and submit to me by tomorrow. Okay, so thank you very much. So don't forget to tick your attendance. Okay, in the U future. Okay. Thank you very much. Don't forget tomorrow night, yeah. So we have diagnostic test again about 30 minutes question. All determinate structure question plus vector plus vector unit and reaction calculation, just like that. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.